Namastey Coders, I hope you are fine. So today is 6th March and we are going to start with the LeetCode 75 problems. So before starting this problem, let me tell you that this video is a part of LeetCode 75 series in which we are committed to solve all the problems from LeetCode 75. LeetCode 75 contains the problems, most important 75 problems of the essay which are most likely to come into your interviews, right? So I suggest you all to see those videos one by one and get handy on all the problems of LeetCode 75. So we have already solved the first problem of every topic till monotonic stack. Now we are solving the second problem, and we have solved all the second problems till binary tree BFS. Now we are gonna start with the binary tree DFS. Okay, so before solving this problem, there is also one video series in which we are committed to solve all the LeetCode daily problems, LeetCode problem of the day. So the link of the playlist is given in the description box. You can check that. I've already solved this problem in the 100% time beat, right? So you can check that problem. Also, there is one more thing. I have also created a WhatsApp group in which we can connect with different coders of the different part of world. There is a interesting concept in which we can create a community of the coders, right? There are different use cases of a community. We can solve our doubts, we can discuss multiple algorithms, we can discuss the industry trends, we can start with the good projects, we can start with some freelance work. So there are a lot of use cases of a community. So I just suggest you all, if you want to connect with the different people, if you want to grow your network, so you should join that WhatsApp group. It's completely free. So let's start with the problem. So this problem is from binary search tree, and the problem is delete node in binary search tree. So we will solve this problem in 3 steps, and this is our standard method for solving any problem. So it's not my standard method, but it's an interview standard method to solve any problem, right? So for any problem, first we have to discuss the details, what is given and what is expected, and then we will try to solve this problem in native approach. Then we will discuss the optimized way. So let's start with the problem. Delete a node in binary search tree. This is a medium type of problem. Topics maybe binary search tree, or let's check what is the topic. Topic are binary search tree, binary tree. So all these are the topics. So given a root node reference of a binary search tree and a key, delete the node with the given key in the binary search tree. Return the root node reference updated of the binary search tree. Basically, the deletion can be divided into 2 stages. Search the node to remove. If node is found, delete the node. So the question is, we have to delete the node. Let's say we have to delete the 3. Then we have to update the binary search tree so that it does not lose its properties. So the properties are, all the nodes in the left side of a root node should have the smaller values, let's say 4, and all the nodes which is right to the binary search tree should have the greater or equal values, right? So let's say 5. So these are the binary search trees. So if we want to remove 3, we cannot just say that 2, 4. We can also do that, but we have to make sure that the binary search tree should not lose its property. Okay, so this is the case in the second example, right? We have to delete 0, which is not present, so we will not do anything and we will return. Okay, so what can we do? So first of all, we have to find that if the key is present or not. Okay, and then we have to delete that key, and we have to replace that key with the second element so that it does not lose its property. So I've already solved this problem. Let me discuss it with you. Okay. So this is a recursive approach. Okay, this is the recursive approach, and this is the base case. If there is no root, so we will return root. What we are doing? So let's say this is the binary search tree. If this is the root node, let's say there are something this is the root node, right? We have to find that if key is smaller than this root node, greater than this root node, and or this root node is a key or not. So if this is a smaller, we have to do the operations in the left subtree. Okay, this is the considered subtree, and now again 5 and key is 3, so key is smaller, so we have to do the operations in the left subtree. Now this is our subtree, 3, 2 and 4, and this is the key. This is the key. So if there is a key, right, this is the case in which we have found the key. If the key is smaller, then we have to do the left subtree. If key is greater, then we have to do the operations in the right subtree. And if we have found the key, so there are two cases in which there is only one node in the left or right. Right? There are three cases. Let me correct myself. So one case is the key is the leaf node, right? If there is nothing in the left and there is nothing in the right, so we will return null. That means we have to just delete it and return null instead of the key, instead of the key node, right? So this is the one case. The second case is if there is only one child, right? So there is 3. If there is only 2 here, no 4, so what will we do? We will delete this key and we will return 2, right? So this is the case. So if the case is let's say something and there is 3 and there is only 2, so delete means we will just return 2. So this is the second case. So see this, if there is only left or there is only right. So if there is left, we will return left, or if there is right, we will return right. This is the second case. But now consider if there is all the both the child, right? So there is 3, let's say there is 2 and there is 4 and something. So what should came inside? What should came instead of this 2 in 3? So the next smallest number before 3, we should replace next smallest number before this 3, right? Next smallest number, the just previous smaller number. So if we do a in order search, right? So in order search or a post order search, what came before 3? So let's say there are multiple things here. In order search, this element will came before 3, right? We should replace 3 with this element or this element which came after 3. So I am deciding to replace the element with the previous element. So what I will doing, I am making a temporary element which is left of this key node, and then I am iterating to the rightmost element, so that we will reach the in order element which came before 3, and then I am replacing the value of our key node with the temporary node, which is this. Let's say this is 1, right? Or let's say this is 1 and this is 2. So I will replace 3 with 2. Now I am deleting this node. So this is a leaf node, so this will get deleted here only, and this will get null. So I am deleting in the left subtree, and value is temporary value. So I will delete this node. so my tree will get updated. So this is the whole solution. I hope you understand it well. Thank you for your time. I suggest you all to join the WhatsApp group, and if you want you can share the group with your friends also. And thank you. If you have any doubt you can ask me directly in the comment section, or you can also contact me on the WhatsApp using the link given in the description box. If you find this video helpful, you can write your valuable insights in the description, in the comment. Okay guys, that's all from my side. Thank you for your time. I hope you have a nice day.